Okay, basically what I'm doing here is going through the Chapter 8 notes package. This is a PowerPoint. The idea is this is what you'd normally doing in the classroom, but I provide it to you in the flipped classroom so you can go through it more than once, twice, faster, slower, whatever you need to do. This, of course, is what you want to fill in, go through as I do the presentation. So Chapter 8 is the culmination of the chemistry you do in this course. It is a very important chapter because by the end of the chapter, you really need to be able to name ionic compounds, write formulas for ionic compounds, and basically be able to recognize when something is multivalent or just monovalent. If that means nothing to you, good, because that's why we're here. So the key ideas in Chapter 8 are that elements, remember all those things on the periodic table, they combine to form compounds in exact proportions. It's not a matter of just throwing a bunch of sodium on a pile and a bunch of chlorine gas and expecting to get sodium chloride. There's exact ratios of those elements. They have to be in those proportions. The formulas of ionic compounds can be determined from their names. If I say sodium chloride, you know that there's sodium as the metal, and you know that there's chlorine as the nonmetal. Ionic just means a metal-nonmetal combination. Usually they're binary in the sense that there's just two elements in that compound. So, the names, on the other hand, of ionic compounds can be determined from their formulas. So the formula NaCl tells you what the formula is. It's basically, it tells you what the name is because the formula is NaCl. Na is sodium, Cl is chlorine, so you know the name is sodium chloride. Notice in binary ionic compounds, you change the ending of the nonmetal to "ide." Sodium chloride, not sodium chlorine. Chemical families are groups of elements that have similar chemical and physical properties. You've already met some of these, the halogens, alkali metals, etc. So, all of the theory in Chapter 8 is actually based on all that stuff in Chapter 7. Remember Bohr, how many electrons you've got in each outer shell, because those number of electrons actually determine the chemical characteristics of combining. So if I gave you magnesium and fluorine, magnesium and chlorine, and magnesium and bromine, you should be able to come up with the right proportions of each element just based on their Bohr structures. I'll give you for instance, I'm going to move on to the periodic table and show you where magnesium and fluorine are. So magnesium is essentially, let's get a pen going here. Magnesium, is right here, and notice it's a 2+ charge. The 2+ charge is why is it there? Basically, it's because that 2+ means that there are 2 electrons in the outer shell of magnesium. How do we know that? Group 2, all of group 2 tells you that there's 2 electrons in their outer shell. And to be stable, you want a full octet. The only way you get a full octet is if you lose those 2 electrons. And if you lose 2 negative electrons, you become a 2+ ion, right? So that's magnesium. On the nonmetal side, you have fluorine. Notice that fluorine is given a charge of -1. Why is it -1? Because it's in group 17. Group 17 tells you that you have 7 electrons in all of group 17's outer shell. 7 electrons is not good at all because it's not 8. They need a full octet, 8 electrons. The only way they get a full octet is by gaining 1 electron. If you gain 1 electron, you become -1. Same thing with chlorine, same thing with bromine. How exciting, right? By the way, how do you tell there's 7 electrons in its outer shell? If you take that group number 17 and you subtract 10, you get 7. How many electrons in the outer shell of the noble gases? 18 minus 10 is 8. That means they all have a full octet. These suckers don't react with anything because they're incredibly stable. On the other hand, group 16 minus 10, 6 electrons in their outer shell, so they want to gain 2 more to have 8. That's why they all form 2 minus. What the heck does this have to do with writing formulas? Well, we just asked, review the Bohr theory for chapter 7. Magnesium, we said, was, let's get this pen going here, magnesium was 2 plus, and we said fluorine was 1 minus. To be a compound, these have to equal 2 plus and negative 1. The only way they can be equal is if you have 2 fluorines, right? 2 times negative 1 is negative 2, which totally balances the plus 2. So the formula for a compound formed with magnesium and fluorine is MgF2. Notice the subscript has to be written lower down. Just tells you there's 2 atoms of fluorine. Each one has a charge of -1, so there's a total of -2 is the total charge on fluorine, which balances the plus 2. What about magnesium and chlorine? Because they're in the same family, magnesium is still 2 plus, but chlorine is just like fluorine, it's -1. So you know that the ratio is basically 1 magnesium. Whoa, let's try that again. I think I'm going to try to erase that. Yeah, that's just darn ugly. On the other hand, it doesn't like my eraser. Okay, we'll ignore that one. Yeah, the ratio would be 1 magnesium to 2 chlorine. And again, that formula would be just like MgF2, but now it's MgCl2. What do you think the formula would be between magnesium and bromine? Bromine's in the same family as chlorine and fluorine, so you guessed it, it's going to be a ratio of 1 magnesium to 2 bromine. In other words, MgBr2. Excitement! Okay. So, to continue, elements combine to form compounds. Compounds are combinations of 2 or more different elements, again in fixed proportions. Usually we either build little models to show what these look like, or we can just simply diagram them. This would be sodium chloride, sodium hydroxide. Sodium would be this puppy right here, the oxygen would be red, and the hydrogen, this little guy. By the way, OH is what's called a polyatomic ion. They tend to be elements that stay together when you form compounds. You have a sheet of them. You're not expected to memorize them, but when you see OH, OH actually stands for hydroxide. So don't try to name it sodium oxygen hydride or something, because it's a polyatomic ion. So you have to get used to using that sheet of polyatomic ions. This, on the other hand, would be chromium trichloride. All the molecules of a particular compound contain the same types of atoms in exactly the same proportions. And I know some of this is redundant, it's repetitive, it's brainwashing. Welcome to education. So example, water molecules always contain 2 atoms of hydrogen to 1 atom of oxygen. There you go. And there was a sheet I believe we did in class that basically emphasizes this proportion idea. You might want to look back at your naming compounds worksheet. So, scientists identify compounds by their chemical formulas. Here is a key phrase for you. Chemical formulas show the types of elements and their ratio in compounds. That's what those little subscripts are for. So it tells you that there's 1 sodium to 1 oxygen to 1 hydrogen in that formula for sodium hydroxide. On the other hand, barium hydroxide would be barium with 2 OH groups. Remember, those are polyatomic ions. If you have more than 1 polyatomic ion, you have to put it in brackets with a subscript. So 2 OH groups, barium hydroxide. A polyatomic ion is a group of atoms that possess an overall positive or negative charge. And again, you have a handout for these. Polyatomic, poly just means many, atomic, many atoms. Yeah, be sure to make corrections to the handout, the common ion chart. There's a couple on there that need to be fixed. If you have the wrong ion charges, all your formulas are going to be incorrect, and that would be just so sad. By the way, there was another sheet we went through in class called C, Writing and Visualizing Chemical Formulas. You should look back at it. So moving on to 8.2, what was in 8.2? Metals and nonmetals. By the way, just because I'm going through this really isn't sufficient to not read these sections. Make sure you read them because they have examples, they have diagrams. You'll get a far deeper mastery of the content. So, metals and nonmetals combine by forming oppositely charged ions. Again, everything you see on the periodic table is neutral. There's no charge. But when you form compounds, those elements are either going to gain or lose electrons to form ions. It's these ions that interact to form compounds. To form ions, atoms must gain or lose specific numbers of electrons. To form ionic compounds, the total number of electrons given up by the metal ions must exactly balance the total number of electrons gained by the non-metal ions. So you may wonder why things like chlorine, a non-metal, is negative. It's because non-metal ions gain electrons to become negative, whereas metal ions tend to lose electrons to become positive ions. The sum of all positive and negative charges in a formula must add up to 0. That is important. That's why we're going to repeat it. When you're writing a formula, you have to make sure that the sum of all positive and negative charges in that formula add up to 0. So in other words, these are all self-checking. You should never get these wrong, because as long as you can add and the positive and negative charges add up to 0, you're right. So let's say teacher says, hey, you have an aluminum 3+ ion and a sulfur -2 ion. What would be the compound formed between those two elements? There is a thinking way which I recommend for such questions, and then there is a easy way out, a shortcut called the crisscross method. Anyhow, the thinking way would involve you saying to yourself, aluminum, let me see, that has a 3+ charge because it has a tendency to lose 3 electrons. On the other hand, sulfur has a -2 charge because it has a tendency to gain 2 electrons. If I form a compound between the metal and the nonmetal, the metal is aluminum, the nonmetal is sulfur, that charge plus that charge has to add up to 0. I don't know about you, but 3 plus -2 doesn't add up to 0. What if I had 2 aluminums though? 2 aluminums, each with a charge of 3+, gives aluminum a charge of 6+. And what if I had 3 sulfur atoms? 3 times -2 is -2, -6. So +6 plus -6 adds up to 0. So there you go. The formula between aluminum and sulfur would be aluminum, and we said that we need 2 of those, and we need 3 sulfur. So again, these are self-checking. You never show these charges in your finished formula. These charges, these combining capacities, are only there to help you come up with the right formula. So I've got 2 aluminums. Each aluminum is 3+. So the total charge on aluminum is 2 times 3, 6. Charge on sulfur is -2, but I have 3 of them. 3 times -2 is -6. That adds up to 0. Cool. Self-checking. You know that it's right. On the other hand, if you are a little skittish about such things and you want to just get the right answer and don't know why, which is never recommended, you can use the crisscross method. Bring this puppy down there, bring this puppy down there, and you're still going to end up with Al2S3 for in the formula, and that too is correct. Right. Moving right along. Yeah, so this just shows you a better version that you can read of the crisscross method. By the way, make sure these are in lowest terms. If this was a 6 and a 3, you'd have to divide through by 2. If it was a 4 and a 2, you'd have to divide through by 2 to end up with lowest terms. In this case, 2 and 3 are the lowest terms, so you don't change it. So that is writing the formula. Section 8.3 is about naming ionic compounds. Metal ions have the same name as the metal element. Duh. Some metals produce ions with different charges. We say they're multivalent ions. Where do you find these, and what the heck are we talking about? Let's go back to that periodic table we had a while ago. There we go. Notice all these transition metals. Nickel can be 2 plus or 3 plus. Copper can be 2 plus or 1 plus. There's a lot of them, right? So the only way in a formula, when we name it, we know which one it is if we actually say which one it is. And we use Roman numerals in order to determine that. So, let's get back to this page, just about there. Yeah, some metals produce ions with different charges. We just showed you them. They're multivalent ions. Each ion is identified with a Roman numeral. So on the periodic table, if it's 3 plus, in the name, we use Roman numerals and say it's iron in brackets 3, Roman numeral 3. Iron 2 plus would be iron in brackets Roman numeral 2. Polyatomic groups or polyatomic ions have special names. We've already mentioned this. We mentioned hydroxide. You have a sheet of these. For example, CO3 with a charge of -2 is called the carbonate ion. If you see CO3 together, don't try to name it as carbon, oxygen, whatever. It's carbonate. Okay, carbonate. Ions composed of a single atom of a nonmetal, again like chlorine, are given the ending "ide" suffix. That's what the ending means. So the ion of oxygen is called oxide. By the way, people often get confused with like what would we call nitrogen if it's the end of a compound? It'd be nitride. If it was phosphorus, it'd be phosphide. If it was oxygen, it'd be oxide. You get the point. So the name of an ionic compound is formed by combining the names of the two ions with the names of the metal ion first. So example, calcium carbonate is calcium carbonate. CaCO3, again, CO3 is that polyatomic ion. We name the metal as calcium. We don't have to change it. But CO3, we have to use our sheet of polyatomic ions and recognize that as carbonate. And again, you have a wonderful little practice sheet that goes through this. This is just an abbreviated sheet of polyatomic ions. You shouldn't have any problem with it. You'll notice I've given you a few problems to try. You don't actually see them in here. So maybe what I should do, is to include these at the end, and you can come back and check your own. I'm thinking it would be better if you actually try them in pencil on your own, just to see if you're getting some of this stuff, and then I'll go through it at the end. But just to finish the PowerPoint, there was a section 8.4 on chemical families. Very quickly, you need to recognize these families: the alkali metals, the alkaline earth metals, the halogens, the noble gases. Notice, of course, that we tend to be going through a transition here from metals to nonmetals in green. So, the elements in group 1, there we go, of the periodic table, except hydrogen, are called alkali metals. They are low density, soft metals that react with water to form hydrogen gas and an alkaline solution. The elements in group 2 are called alkaline earth metals. They are low density, hard metals, and are commonly found in minerals. The elements in group 17 are called the halogens. They're bright gases, and they're all bloody toxic in elemental form. You don't want to touch, breathe, etc. Highly reactive. And of course, the elements in group 18 are the noble gases. Non-toxic, colorless, non-reactive. We say they're inert. They don't react. They have that full outer shell. They're stable. Okay. The only section in this PowerPoint that I haven't actually given you answers to are the try a few and naming compounds. Because this is the kind of question that's going to turn up on your test, it probably is a better idea if you try these on your own first. But you want to make sure that you're getting feedback and you actually know you're on the right track. So the first question asks you to give a formula. I give you the name, calcium and chlorine, and then you have to give me the formula formed between those two elements. So in the case of calcium, we basically would write calcium and then check the periodic table. Calcium has a charge of 2+ because it loses 2 electrons. Chlorine, on the other hand, has a charge of -1. You could just write minus or -1, it doesn't matter. Those values then are going to be used to come up with the correct formula. The thinking is that that plus that has to add up to 0, and as you know, they don't. But if you had 2 chlorines and 1 calcium, then 2 times -1 is -2, which balances the +2 on calcium. That is the correct formula for calcium chloride. Notice I changed the ending to "ide." By the way, you never put in a 1 as a subscript, so don't worry about the 1. Anyhow, the next one was oxygen and calcium. Oxygen is -2, or 2 minus. Calcium is +2. So again, just to mess things up in your mind, I have put the metal ion second here, but in the formula, you always have to have the metal ion first and then the non-metal. 2 plus -2 adds up to 0 already, so the formula is just Ca. Oh, Ca is 2 plus, O is -2. They are in a ratio of 1 to 1. They add up to 0. Perfect. How about sodium and hydroxide? Sodium is +1. And what the heck is hydroxide? Hydroxide is a polyatomic ion. You need to look at your sheet of polyatomic ions, and you'll see that hydroxide is -1, and it's OH. +1 -1 adds up to 0, so the correct formula is just NaOH. Perfect. How about calcium and nitrate? Calcium is 2 plus, if I remember correctly. And nitrate, again, nitrate. There is no nitrate on the periodic table, so you know it's a polyatomic ion. Check your polyatomic ion sheet, and you're going to see it's NO3 with a charge of -1. Now, +2 -1 doesn't add up to 0. What if I had 2 nitrates? So you may be tempted to go like this, CaNO3, and you said 2 nitrates, so you put a 2 there. No, because that would be 32 oxygens in nitrate. All you want are 2 nitrates, so you put nitrate in brackets, CaNO3, and you've got 2 of them. Check that your answer is correct. 2 times -1 is -2, which balances the +2. Number 5 there is tricky, because, again, I messed up the order. You have to have the positive or the metal ion first. Ammonium is NH4. It's a polyatomic ion. It's +1. And phosphate, if I remember correctly, is -3. And again, you don't use these. These never turn up in your formula. They're just the charges that allow you to come up with the correct formula. You need 3 ammoniums because you have to balance that and add up to 0. The only way you can have 3 ammoniums is if you put ammonium in brackets, NH4, 3 of them, and then the PO4. Cool. The total charge on the above compound, this NH4, 3, let's check it. 3 times +1 is +3 plus -3 adds up to 0. That's going to be the charge on any compound. Cool. The naming compounds, why don't we erase this if we can? Most people find the naming side of things much easier. Wow, the erasing, this is exciting, eh? It's probably some lovely little control where I can erase the whole puppy at once. That would be so cool. Okay, bell's about to go here. I don't want the bell to turn up here. So AgCl, Ag, you know, is silver. So there's the first part of the name. And then you have chlorine, change the ending to ide, silver chloride. Make sure in a binary compound with 2 elements you change it to ide. Mg you recognize as magnesium. Magnesium and oxygen, again, there's just 2 elements in this compound, so you change the ending to ide. Zinc, you recognize. And then OH is hydroxide. Right, polyatomic ion, it's not on the periodic table. NH4, you'll come to know and love from your periodic table, not your periodic table, your sheet of polyatomic ions, as the only positive polyatomic ion, ammonium. And OH, you already know, is hydroxide. And then we get nasty because I'm actually giving you the name already. For number 5 and 6, you need to come up with the right formula. Why don't I tell you that the Roman numeral 2 there tells you that it's lead 2+, oxygen is -2, so it's just PbO. How about lead 4? Now it's Pb2+. You're going to need 2 oxygens, PbO2. Again, if you have any problem with any of these, do make sure you talk to me, get some help, and you can do it.